Okay, so in this series, in this unit, we're going to cover a lot of what you covered in geometry. It's just a rehash of the concepts of geometry. This is a big deal. You don't see a lot of this in college algebra. However, it is really, they say, high 40s, 50% of the ACT, but there are a lot of geometric concepts on the ACT, so I felt like this was a good time to go back over this to kind of rehash it, maybe if you're taking the summer ACT or if you just need to hear it again. So Pythagorean theorem is something you learned in 8th grade. So we know the formula is side squared plus side squared is equal to the hypotenuse squared. So a squared plus b squared is equal to c squared. So if you want to find a missing side, you figure out whether you're looking for a side or the hypotenuse and then plug into the formula. So number one, we are very clearly looking for the hypotenuse. So I have a squared plus b squared equals c squared. So 4 squared plus 8 squared is equal to c squared. So the square root of 16 plus 64 is equal to c. So c is equal to the square root of 80, which we now can simplify radicals hopefully quite easily. So we need to figure out the perfect square in 80. The perfect square, the largest perfect square is 16 times 5. So then the square root of 16 is 4 square roots of 5. So number 22, they kind of twist the triangle around, I think, to try and confuse you on what you're looking for, so that they kind of hope that you'll think, oh, that's the hypotenuse, because this one was the hypotenuse, and they're almost in the same place. But remember that the hypotenuse is always across from the right angle. It's the largest angle in the triangle, so it has to be the largest side. So we're clearly looking for a side. Now, it doesn't matter whether you label it A or B, you're going to get the same answer. So a squared plus b squared is equal to c squared. So we'll just go with b. So b squared is equal to c squared minus a squared. So b is equal to the square root. C squared is the hypotenuse, so order does matter. 24 squared minus 22 squared. So b is equal to, you can just plug that in the calculator. So 24 squared minus 22 squared is the square root of 92. And we need to find the largest perfect square, which is actually quite small. It's divisible by 4. 23 is prime and not a perfect square. So then b is equal to 2 square root of 23. Pythagorean theorem. Okay. Something else that you learn about in geometry is special right triangles. So they have a very special relationship. So the first is a 45, 45, 90. So remember, in a 45, 45, 90, you have two sides that measure the same and then the hypotenuse. So we have a leg that's going to measure whatever the leg measures. Both legs have to measure the same thing. And then proportionate to those legs, the hypotenuse is going to be whatever the leg is times the square root of 2. So if this is 2 and this is 2, then this is 2 square roots of 2. If this is 3 and this is 3, then it's 3 square roots of 2. Okay? So remember, the second one is a 30, 60, 90. So the shorter leg is across from the small angle. The longer leg is across from the 60 degree angle. And then, of course, the hypotenuse, as it always is across from the 90 degree angle, the right angle. Okay, so the shortest leg is x, so this is x across from the 30. The longer leg is whatever the shorter leg is times the square root of 3. So x times the square root of 3. And the hypotenuse is 2 times whatever the shortest leg is. Okay? So we have our ratios. So then it says find the missing side. So clearly we cannot use Pythagorean theorem here because Pythagorean theorem only works if you have two sides. So if you're missing two sides, it's likely a special right, and that will be labeled for you. Notice it has the 45 here. So the first thing we know in a 45-90 is that my two legs have to be the same. So if this leg is 10, then I know that this leg must be 10 as well. And we also know that the hypotenuse is whatever the leg is times the square root of 2. So that would just be 10 square root of 2. So number 4, we know that our legs have to be the same. Now the problem is we have the hypotenuse. So we have to think, okay, well, what is the relationship between the hypotenuse and the leg? And we know that the leg is equal to the hypotenuse. Well, let me say this another way first. So we know that whatever the leg is, the hypotenuse is equal to the leg times the square root of 2, right? That means that the leg would then be equal to the hypotenuse divided by the square root of 2. Okay, so then I would do 16 divided by the square root of 2, which we know we cannot leave it like that. We have to rationalize. So I'm going to multiply top and bottom by square root of 2. So I get 16 square root of 2 over square root of 4. And the square root of 4 is 2. And 2 divided by 16 is 8 square roots of 2. And again, we know that our legs have the same measure, so x and y have to be equal to each other, okay? So number 5, another 45-90. So we have the same thing. The hypotenuse is the leg times the square root of 2. So this one doesn't take quite as much effort. If you divide this by the square root of 2, well, what happens to the square root of 2? Goes away. So my two legs must be 14 and 14. So number 6, this is a 30-60-90. So across from this is the short leg. So remember that the hypotenuse is equal to 2 times the short leg, okay? Which means that the hypotenuse divided by 2 is equal to the short leg. So 8 divided by 2 is 4. So my short leg is 4. Now my long leg, remember, is the short leg times the square root of 3. So I have my short leg now, so this is 4. And my long leg is 4 times the square root of 3. So just multiply by the square root of 3. Number 7. So we have the long leg, okay? So I need to go back to the short leg. So remember that the long leg is equal to the short leg, which in this case would be y, just because that's the way they labeled it, times the square root of 3, which means I can find the short leg by taking the long leg and dividing by the square root of 3. So I have 27 divided by the square root of 3. So again, we rationalize. We get 27 square roots of 3, and square root of 3 times square root of 3 is 3. 27 divided by 3 is 9 square roots of 3. So 9 square root of 3. So don't let their mixing up x and y's, a's and b's, or whatever they want to do distract you, because it can be very easy to label that as x, but x is the hypotenuse. So in a 30-60-90, the hypotenuse is twice the short leg, and our short leg is 9 square roots of 3, and twice that would be 18 square roots of 3. 9 times 2, right? So in number 8, if this is 60, this is 30, so we're actually given the short leg. So again, if you'll look at your ratios, the long leg is the short leg times the square root of 3. So that would be 5 square root of 6 times the square root of 3, which is 5 square root of 18, which we need to simplify, which gives me 15 square roots of 2 for my long leg, which is, in this case, y. And remember that the hypotenuse is twice the short leg. So if my short leg is 5 square roots of 6, then twice that is 10 square root of 6. Okay. Trig functions. A trigonometric function is a function whose rule is defined by a trig ratio. A trig ratio compares the lengths of two sides of the triangle. The Greek letter theta is often used to represent the angles in a triangle. So this, my dears, is just SOHCAHTOA. It's fancier because they're using all this trig ratio stuff and thetas and fanciness, but it's still SOHCAHTOA. The same thing you learned in geometry. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. Okay. So what you may not have talked about in geometry is the reciprocal functions. So cosecant, which is CSC, is the reciprocal of sine. It just means that we take sine and put it under 1. So if sine is opposite over hypotenuse, then the reciprocal would be hypotenuse over opposite. Secant is the reciprocal of cosine, so it would be hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which would be adjacent over opposite. Okay? So, for example, it says to find all 6 trig ratios for the theta shown in the triangle. So we look at what theta is, where theta is placed, and we do SOHCAHTOA based off that. Okay, so in order to complete SOHCAHTOA, I have to have the hypotenuse. We have 16 squared plus 30 squared is equal to c squared. So the square root of 16 squared plus 30 squared, which I'm just going to type in the calculator, 16 squared plus 30 squared is 1156 is equal to c. So square root of 1156 is 34. Always check to see if it's a perfect square before you start trying to simplify. Never hurts, especially if it's a large number that you're not so familiar with. Definitely do that. Okay, so we can just start with SOHCAHTOA just like we know. So sine is opposite over hypotenuse, so opposite 16 over 34, which reduces to 8 over 17. Cosine is adjacent, so the angle, the side adjacent to hypotenuse, so 30 over 34, which reduces to 15 over 17. Tangent is opposite over adjacent, so 16 over 30, which reduces to 8 over 15. Now, reciprocal functions are quite easy. You just take the reciprocal. So cosecant is the reciprocal of sine, so 17 over 8. Cosine is secant is the reciprocal of cosine, so that would be 17 over 15. And cotangent is the reciprocal of tangent, which is 15 over 8. So it gives me the ratio for cosine and wants me to find the remaining ratios. Before I draw my triangle, which I need a triangle so that I can do SOHCAHTOA, I would go ahead and find secant. It's very easy. It's the reciprocal of cosine, so 3 over 2. So then I'm going to draw my my triangle. So I have, so wherever you put theta is where you have to do your ratio. So remember that cosine is the adjacent over hypotenuse. So adjacent would be 2 over hypotenuse 3. Now to find the missing side, we would have the square root of 3 squared minus 2 squared is equal to b. It doesn't matter whether you choose a or b, makes no difference. So then we have the square root of 9 minus 4 is equal to b. And so we get the square root of 5 is equal to b. So that means sine is opposite over hypotenuse. So that's square root of 5 over 3. And tangent is opposite over adjacent, which is square root of 5 over 2. So the reciprocals, you just take the reciprocal, 3 over the square root of 5, which we cannot leave it that way. We're going to rationalize. So 3 square roots of 5 over 5. Multiply top and bottom by the square root of 5 to rationalize. Same here, 2 over the square root of 5. Multiply top and bottom by square root of 5. And you get 2 square root of 5 over 5. Remember the square root of 5 times square root of 5 is square root of 25. Or the square root of 5 squared. Either way, you get 5. Now this gives you some exact values for sine and cosine and tangent by using right triangles. This is something that I would hope that we can get to, but I don't know that we're going to have time to make it there. If you've talked to anybody in Algebra 3, they do this using the hand trick. This is where these special values come from, is these right triangles. So remember the ratio for 45, 45, 90 looks like this. And for 30, 60, 90, the short leg is my x. My longer leg is the short leg times the square root of 3. And my hypotenuse is twice my short leg. Okay? So if you look at these, if we want to know sine of 45, so you can pick either 45. Remember sine using SOHCAHTOA, again, that's like your lifeline with right triangles. So SOHCAHTOA says it's opposite over hypotenuse. So x over x square root of 2, which reduces to 1 over square root of 2, which rationalizes to square root of 2 over 2. Okay. Cosine of 45, adjacent over hypotenuse. So same thing. And it plays out exactly the same way. Tangent is opposite over adjacent, which reduces to just 1. So sine of 30, so here's my 30, right there. So sine is opposite over hypotenuse, which reduces to 1/2. Cosine is adjacent over hypotenuse, which reduces to square root of 3 over 2. And tangent is opposite over adjacent, which we then rationalize to the square root of 3 over 3. So 60, so from right here, sine is opposite over hypotenuse, so x square root of 3 over 2x, which is 1/2. Not 1/2, square root of 3 over 2. Cosine is adjacent over hypotenuse, which is 1/2. Notice these values flip-flop. And then tangent is opposite over adjacent, which is square root of 3. Okay, so for homework, I want you to look on page 2. It says homework 1 at the top. Homework 1 at the top. I want you to do number 1, 2, 3, 4, 5, number 7, 9, and 10. So to be clear, that is page 2. 1, 2, 3, 4, 5, 7, 9, and 10 on a clean sheet of paper. You should have over 30 minutes left to class, so this should be no trouble to finish and turn in today. Okay?